Hi, this is 12.5. We're going to talk about samples and surveys. So the first thing we're going to do is present you with just a real life type of problem. So a manager of a Thai restaurant wants to know how often people in her city eat Thai food. Okay, she surveys 200 of her customers. The manager says the results of the histogram show that most people in the city eat Thai food at least 10 times per year. Do you think there are any problems with the survey? Well, I don't think we have to think about do you think there are any. Okay, what are the problems? So what could be some possible problems? Well, keep in mind the survey. Right? The survey is asking about how often people in the city eat Thai food. So we want to talk about all the people in the city as the population. So that's everybody. Now the manager is only checking with who? Okay, so she surveys 200 of her customers. Now what type of restaurant does she have? She has a Thai restaurant. So already she's limiting her sample size to a very small part of the population. So to say that the 200 people in her Thai restaurant are going to eat there at least 10 times per year, it's kind of a bias into what's going on here because they're already in a Thai restaurant to ask them about eating Thai food. So hopefully through that little explanation, we kind of see a little bit of some things we're going to talk about. You heard some of the vocab we'll go through in the next couple of slides. Alright, so you can collect data using measurements or categories. So measurements often mean we're talking about numbers, right? Categories could be anything else. Quantitative data measure quantities, right? So quantities here again are numbers. Can be described numerically. There you go. Such as test scores and ages. Qualitative, name qualities, and can be words or numbers such as sports or zip codes. So as we take a look, so which type of data has units and can be measured numerically compared? So ages, weights, times. Okay, hopefully through all that, you see that we're talking about quantitative. To describe a category, as soon as you see category, we know it's qualitative. And then some examples we have over here. The hair color is brown. Attitude is optimistic. Zip code is 02125. So although the zip code has a number, it doesn't automatically qualify it as quantitative. So let's try a couple of these. Is each data set qualitative or quantitative? So if we have favorite movies, well, favorite movies is kind of like your opinion. It's a category. So these are not numerical quantities. These are qualitative data. So qualitative. Okay. Our next one, we take a look at number of students in different schools who take Spanish. Okay. We're talking about a numerical number of students in different schools. This is quantitative. And football jersey numbers. Okay. So the jersey number is a number, but it's not something we can measure. So if they're not measurements, then that is qualitative. It's just something about the jersey that it happens to have a number on it, so qualitative. Alright, is each data set qualitative or quantitative? Explain. So the cost of CDs. So the first thing is, what do you think? Is it qualitative or quantitative? If you're thinking quantitative, you're exactly right. So the cost means we're talking about the price for the CDs, and we can exactly figure out what's going on with that. Now, eye color, of course, we tried to give you one of each, so it's going to be qualitative. Okay, and that is a quality, if you will. Okay, so an eye color is quality, what we think of someone, right? So it describes a category, cannot be measured. So if we can say hair color, we could say eye color. So that should automatically fall in there. All right, a couple more things we want to talk about. The kind of data you are working with determines the type of graph you use to display the data. A set of data that uses only one variable, so here's kind of a key right here, right? We're talking about one variable is going to be univariate, right? One meaning uni, of course. Okay, and a set of data that uses two variables, so key part of here is 2, and prefix for 2 is bi, so bivariate. So I'll get you your key here, 2. So 2 is going to qualify as bivariate. And where, of course, 1 is univariate. This is a little bit easier to identify because we're really talking about one thing or two things. Okay? Atomic weight of the elements in the periodic table. Okay, well, if it's the atomic weight, it's the atomic weight. And it only has one atomic weight. So uni. And the edge lengths and volumes of cubes. Okay, so that is bivariant. So we want to make sure that we have this idea. Is each set of data univariate or bivariant? Explained. So we have the same thing. The heights and weights of mammals. Heights and weights is bivariant. And by saying heights and the weights. Okay, that's how we get, so I'm good with that as an explanation. The cost of internet service from several different providers. Okay, well, if you have an internet service provider, you have one of them. And their cost is going to be one cost. The fact that you're comparing the many different ones doesn't matter. You're still talking about the cost of each one. So we're talking about univariant. Okay. We're talking about the cost of one. Like I said, we have a lot of vocab in here, so I want you to take some time and read through what we have. The big idea is that we're going to have an entire population, so that's the big circle. Right? So the entire population of the city, when we're talking about the Thai food in the opening question, the sample is the number of people you take out of the population. Because in most cases, it's not going to be ideal or it's not going to be possible at all to actually survey the entire population. So we have to have some sample. And here are the ways that you can have samples. You can have a random sample. Survey a population at random. Okay, so survey people whose names are drawn out of a hat. So that would be random. There's no way that we're picking them, like every third or people with the name Billy, anything like that. Systematic. So systematic is used often. That way it helps out with this random selection. So select a number n at random, then survey every nth person. So select the number 5 at random, then survey every 5th person. So this could be you and ask a question about, the cafeteria. So every 5 people in the school, you ask them about the cafeteria, instead of asking everyone or randomly picking some people. And stratified. We want to separate a population into smaller groups with each with a certain characteristic. Then survey at random within each group. So maybe you want to survey something about the cafeteria, but you want to find out if the guys and the girls have a different feeling about it. So we start to split the whole thing into 4 categories by grade level. Okay, so I give the example of guys and girls. Here they give the example of grade level. So survey a random sample of students from each grade. So we want to make sure that we get a random number in each grade. Okay, so we have random, systematic, which is still somewhat random, but you have a system to how you're going to be random, and then stratified is really putting those groups. Okay, so that's kind of the catch there. So you want to find out how many DVDs students at your school rent in a month. You interview every 10th teenager you see at a mall. What sampling method, so this is question 1, what sampling method are you using? So if we're picking every 10th teenager you see at the mall, hopefully you're writing before I am. Number 1 is then going to be systematic. Okay, number 2, so question number 2, is this a good sample? So population, what's the target population for this? You want to find out how many DVDs students at your school rent. Okay? So the question is about students at your school, but where are you doing the surveying? So you're going to take every 10th teenager you see at the mall. Okay? Now, I would guess that if you went over to the Galleria, our local mall here, you wouldn't see just York Suburban students. So we start to see that there is a problem with it. So we're going to say, is it a good sample? We're going to say no based on that. Okay, so you will not only be surveying. So not only your school at the mall, or your school, your peers. Okay, peers. Maybe I should say school here, but you get the idea. Alright, so we start to see that we want to make sure that you have a method. So our method is systematic because we're going to survey every 10th, and then you want to make sure you're sampling based on what your question is. A reporter wants to find out what kinds of movies are most popular with local residents. The reporter asked, do you prefer exciting action movies or boring documentaries? Is the question biased? And so first you have to examine what in the world does bias mean? Okay, obviously as a baseball coach, I have a bias that I like baseball. Okay, but I try and be open-minded to it, and I won't push you into anything. But here, what is the reporter trying to push the sample size into saying? Okay, do you prefer exciting action movies or boring documentaries? So when he throws these extra words in here, exciting and boring, those are his opinion. Okay, so is the question asked is question biased? We're going to say yes to that, and my explanation is just highlighting these key words. And the last thing we want to do is take a look. How can the question and problem for? So we're going to take the draw your arrow back up to here. Be reworded so it's not biased. So I'd like to hear, how your question comes out. So go ahead and scribble something down here, not just a squiggly line like I have, but give me something so that we can talk about this in class, talk about bias, and how to fix those bias. All right, 2 more questions that we'll take care of together, and we'll go from here. So let's go. Let's grab a different pen here. I like all these different colors again. So sports, you want to determine what % of teens ages 14 to 18. So here's what you're talking about. Teens age 14 to 18 watch wrestling on TV. So that's the question. Do you watch wrestling on TV? Oh yeah, by the way, we only want to talk to 14 to 18-year-olds. At a high school wrestling match, you ask every third teenager, so you're asking every third teen whether he or she watches wrestling on TV. How might this cause bias in the results of your survey? Alright, so we have an entire population. We're going to narrow that population down to teens, but where are we asking the question at? We're asking the question at a high school wrestling match. So what bias might you have? Well, if I'm going to pay money and go to a high school wrestling match and take time out of my day, out of everything else that I have to do, to go watch wrestling at the school, I'm guessing at some point I might flip the channel over. Okay, so we're going to say that the bias is based on, so bias is in the location. Because I'm guessing this number is going to be higher here than if I were to ask every third teenager at the mall if they watch wrestling on TV. So we're going to keep in mind how to eliminate those. So the bias in this one is based on the location. Alright, and last one. You want to know how many of your classmates have cell phones. Okay, to determine this, you send every classmate an email asking, do you own a cell phone? How might this method of gathering data affect the results of your survey? Well, here's all I have to say, is I get a lot of emails. I don't reply to all of them. So this is, what we're basically saying is since it's email, email is optional. Okay. So how could we fix it? Ask them in class, face to face. So, do you have a cell phone? Yes or no? Here we go. Done. Alright, just a quick lesson check here. We want to go through these 6 questions. Make sure you bring your answers into class. So first, we're talking about determine whether each sampling method is random, systematic, or stratified. Remember, these go in higher sophistication as we go, so make sure you have those. Qualitative and quantitative, that's where we started today. Explain why. Do you prefer delicious fruit or plain vegetables? For a snack food is a biased. So we're looking for that biased, so explain why. And last one, what is the difference between univariate and bivariate data? And give it an example of each. So this one might be a little bit different. If you want to build on an example in the notes, that's fine.